Gravity is the only force that does work, and so it is justified to use the conservation of mechanical energy because gravity is a conservative force. We used the small angle approximation to make it work. In the case of the spring, we had that the potential energy was proportional to x squared. And out came a perfect simple harmonic oscillation. No approximation necessary. Now we forced this potential energy, we forced it into being dependent on theta squared. That's really what we did. You see, that is the term of the potential energy that you have there. And by the approximation of cosine theta being 1 minus theta squared over 2, we forced this term to become quadratic in theta, and therefore now, with that approximation, it becomes a perfect simple harmonic oscillation. Now comes a key question. I said gravity is really the only force that does work. Is that true? There's no friction for now. Is that really true? When we had the pendulum, it's true there is gravity. That's clear. There's a gravitational force, which is mg, but there is also tension. We never mentioned that. We didn't even talk about it when we did the conservation of mechanical energy. When the object is here, sure, there is gravity. And sure, there is no friction, so there is no force along the arc, but there must be a normal force. Is the tension not doing any work? Is the normal force not doing any work? Did we perhaps forget something? Remember last week I put my life on the line. I was so convinced that the conservation of mechanical energy was going to work that I almost killed myself. Not quite. With this huge 15.5 kilogram pendulum that I was swinging. I believed in the conservation of mechanical energy. And I overlooked the tension. Is it possible that the tension does perhaps positive work? If that's the case, I could have died. What is the answer? Is the tension doing any work? And in the case of my circular track, is perhaps the normal force doing any work? What is the answer? I want to hear it loud and clear. No. No. Why is it no? Why is it not doing any work? Because what? Exactly. You got it, man. That's it. The force is always perpendicular to the direction of motion. And since work is a dot product between force and the direction that it travels, neither the tension nor the normal force does any work. So don't overlook the force, but do appreciate the fact that they don't do any work. Great.